here. My name is Jakub and I work at Pitch during the day, and then I hack on overselves and shell scripting and command line during the evenings. Today I'll be talking about shell scripting and how to make it simpler with Clojure. So why even talk about command shells? It's something in the background, in the dark. And the important thing for us developers is that it's a tool we use daily. We use it for our development workflow. And also a lot of our production systems depend on it for orchestrating scripts. The agenda is, I'll first speak about, briefly show the history and good parts about shell scripting and Bash. Then mention the bad parts. We will see a different approach using Clojure. I will talk briefly about simplicity and the shell architecture, and then present some ideas for future exploration. So the history when Unix was introduced, at the beginning there was some evolutions of shell, but then something happened, and in the year 89 Bash was introduced. And it's been a dominant player ever since, which majority people use. And looks like not much happened since then. The good parts about Bash is it's based on the Unix philosophy, and which is to compose programs. And we as functional programmers like composition. The other thing is it's expressive to run commands. You can just type in the command without any extra syntax and its arguments, and it will run it for you. So in general, it's a very useful tool and works great, right? So let's see what are some other nice things that people say about it. Worst thing ever created. Hate. Hate it. This one is an interesting point. We have all our immutable infrastructure, and that is held together by a pile of messy shell scripts. And when writing more than 5 lines, it is very painful. So these are the bad parts, in my opinion. During its evolution, Bash accumulated a lot of complexity, and the many small tools that are often not so small, and they have overlapping functionality. So you start with one, but it is not enough. You start with the grep, then you have to go to set and learn alg, completely different programming language. It operates on unstructured text, but we usually want to manipulate with information and structured data. And this has some dangerous implications that if you have spaces in file names, the scripts can often break if you are not careful. So in general, it is very hard also to learn for beginners, because the way is you read the manual page and then you need to write some command line and you need to go back to the manual page. It doesn't provide much interactivity to help you with that and suggest you some features that you can use to accomplish your task. So in general, I would say as a developer, it is hard to justify learning all the Bash gotchas, because as a developer I need to write a script once or twice a month. So it's a big cost to pay. So what if we take all the good parts of shells and try to combine it with a well-designed programming language, one that is expressive, composable, and has first-class data structures and rich set of library of functions to operate on that. And since we all are in this conference, the language is Clojure. So here I have my terminal, and I like colors. It shows me the path, that directory where I'm in, git branch, which is useful, and changed files. For this talk, I'm gonna switch it to a more simple prompt, so we have more space. So regular commands work as usual. When I type anything without parentheses, I'm typing as in the shell, so I can use all my tools that I'm used to. The interesting part starts to happen when I type parentheses and I start writing Clojure code. I can call functions. And then where it gets even more interesting is that I can combine commands and input from the Clojure computations. Standard redirects also work, so we can work with files as usual. And we even have conditionals. So in Bash, you have the double ampersand as a conditional. And this actually works by the way that true is an actual program which returns exit code. But we can also use arbitrary Boolean expression to achieve the same result. All right, so we can list files as usual. We can use glob expressions to narrow things down. And then we can use pipes. And if I type parentheses, I'd like to try call some Clojure. So we can combine input and output from the commands with Clojure code. And if we send it back to commands, we get the strings again. Now, if we want to list the files and we want to count the number of lines, does anyone tell me how to do it with regular Bash? Yes, we use the toilet command. All right, and here we have a special operator which takes the input and splits it by new lines, so we get seek. So we just call Clojure functions to get the same thing. You can call any function from the library. So maybe we want to reverse. And then if we have a seek and pipe it back to a command, we connect it with the new lines. I have one example. I have a function called extension, and I already defined it before and have it in my environment. And I can call it like so to get the extension of the file. So now if I want to list some files, I can pipe it and map it over the function to extract the extensions of those files. And for example, now I'm curious what are the counts for each file type, so I can tap into another function from the Clojure library. Oh, typo. There we go. I get the counts. Very useful. Now, we can define custom functions. So I can define helper from EDN with as a defined function. And we also define, we have macro called def command, which allows me to then run the command as if it were regular command. So with the so I can call it even without parentheses, get some output. So maybe I want to extract some data. So how about list of dependencies? And maybe pipe it to get a list. These are the dependencies of the projects. As developer, I also often need to work with JSON. You have a sample JSON file. And oftentimes people like to use clojureD to extract data. But this is another tool that one needs to learn, needs to install. It has different language, different domain-specific language. But we already have a language which is good for manipulating data. So you can just get JSON, extract version, achieve the same result. All right, so have a XML file, because this is where this is going. All right. So you get it as an XML, maybe extract the attributes. So the great thing is that we have the Clojure data structures. So we can use any tools. We can use get-in, or we can zippers. We can pull additional libraries like Meander or Spectre, whatever are you familiar with in the workflow. One thing about shells is that the output is text. So if I want to now filter the files based on their sizes, I have to pull in another command because ls does not support it, and parsing is very brittle. So you can try to have some wrappers. So have a new ls, which will give us data, which is not so useful. We might show them in a table. But that's too many columns. So how about we narrow it down a little bit? So we can map it. Maybe select only those columns that we like. And so you get only the 2 columns. And yeah, how about use the pipeline and filter some of the data. So let's say figure out the non-zero. Get only the non-zero files. So we compose predicate, grab the size, and then check if it's a positive number. And we got rid of all the zeros. And we have one more thing. Since this is can pull any Clojure library, I like the experimental Cognitex Rebel. And so we can pipe out the input into Rebel, and we can interactively explore our data. All right. So what you've seen is a project I've been working on. So it's called Closh. It's a standalone Unix shell. It has many features that are needed for regular use: file redirects, prompts, tab completion, history search. The one really great thing is that you can define aliases, but also your functions and user commands, and some syntax highlighting in the JVM version. You can use it as an interactive shell, so when you start your terminal, you're already in it, and you can also write scripts with it. And now let's talk about the simplicity, which I also put in the talk of my title, because it's a really important topic. So far I've been talking about usefulness and power, but simplicity is also important. I will talk about it in a sense as defined by Richie, and the thing is, I think existing shells are complected. And actually when I started, I wanted to just try a different UI for Bash, then use Bash as a library maybe, evaluate it, get the data back. But it was so intertwined, it was impossible. So instead, a couple of years later, I embarked on this journey on building my own shell. Here we are. So the composition is one of the ways how to achieve simplicity. We put smaller pieces together, but there's a note that it is necessary condition, but not sufficient. So even when we divide software into parts, it might not be simple, but I'll try to show you that the way we decompose it, it is about the simplicity. So first I start with the ClojureScript implementation, and we have a readline library which takes the user input and passes it through the reader. Interesting part is that the ls example above, it's proper Clojure form because it's just symbols. And this was when I started, I was like, yeah, I can just use the Clojure reader and do some manipulation on it and I'm done. But there are some syntax that is useful, which is not valid Clojure, like IP addresses and paths, which would be invalid namespaces. So we have to have a customized reader, but then we pass it through parser. Since we have conditionals, there are different operator precedents, so we parse it, have some internal representation, then a compilation step, which transforms it into the implementation, and then we pass it to eval. And in case of ClojureScript, we're building on Lumo based on Node.js, and we have a small box for platform-independent code, which is using the spawn provided by Node.js to run external programs. And then when the result is there, you can also print, and the front end can handle the way how to print it, can enrich it with colors and other useful information. And if you squint a little bit, you can see loop as a REPL, which is a very well-known pattern, and you can replace the parts as needed. So what if we want to run it on JVM? We have all the Java libraries and other useful things. So we can take our RL wrap, which is used by Clojure tools. So readline implementation, we don't need to implement anything of our own, and then pass it through it. And we have eval, which is provided by Clojure compiler, running on JVM, and as a platform we use Java APIs, the process builder. Then if we want to add syntax highlighting, we can add another front end, and we can reuse the work by Bruce Homan, which does all the heavy lifting, and there's a great implementation with auto-completion and colors, and we can hook auto-completion to also complete for files. And we have a new front end. Then, yeah, Java starts slow. It takes a couple of seconds to start, which is not that bad, because you can run it at the beginning of your day, and then you work. But sometimes can be annoying. So what can we do about it? We try more. And recently there's implementation of SCI, small Clojure interpreter, which can be then compiled with GraalVM into native image. And we can reuse the same platform code and only add the eval wrapper. And if you are interested in more, you are in luck, because Michael, the creator of small Clojure interpreter, is going to be talking next. So stay in this room, don't go anywhere to learn more about it. Then there are the questions, on the how can we use pirated structural editing, or it takes too much RAM? Can we do something lighter? So yeah, we could reuse the code to parse and compile it and create our own platform wrappers. So these are some thoughts for future experiments. So currently we have variants. We have the Java one, which I would recommend and I personally use. It's a full-featured. You can include any Java libraries. The command line API is similar to based on Clojure main, so it's familiar. Then there is a GraalVM port, which is big with asterisk. It's not yet completed. It's in progress and getting really close. The advantage is that it has instant start. But there's some limitations. You cannot include all Java libraries. And then there's also ClojureScript, Lumo-based one, and you can include npm libraries, but it's more limited. The script mode is not implemented there. So you can install it if you just download the jar and make it executable. It contains special header, so then you can also use it with shebang syntax to put in at the top of your scripts. It will run. The depths even, you can run it from the command line, pulls down the source, or you can use it just a part as a macro, which is a more convenient way how to call external programs in your projects. And the ClojureScript version we install with APM. It works on Mac and Linux. We didn't test Windows, but might work. Maybe it needs little tweaks. And now I have some time left to quickly go through some different ideas. Currently we have like the baseline, but I think there are much more interesting ideas we could explore. So currently shells are just, if you want some interactive help, it's just a list of auto-completions. But what if we have instead rich textual widgets? There's a cool library, Trickle, which allows you to build textual terminal interfaces with hiccup widgets. It might be a great project to try to include that and add it as a new front end. Then improvements to the editing itself. So you can either use pure Clojure editor implementation, which is very flexible and keeps its state as a Clojure data structure, and all the operations when you type keys is pure functions, so you have really power to control every aspect of it. Sometimes the text editing on the command line and text editor, there's no clear boundary. So what if we pull in a proper editor and we can edit our command line with proper editor, maybe using Vim as a library? Then if we go back and get inspired by smart work of Lisp machines, then the text that the command outputs now is a dead text. You cannot do anything. And with Lisp machines, there's like interactive objects, so then you can list the functions that the object supports, or when you start typing functions, it can highlight you which objects on the screen can be used as parameters. And the really future way is, there might be some interesting idea how to combine graphical ways like launchers with shells to make them even more accessible and easier to use. Then on the backend side, there are also great ways we could do that. Currently, the platform implementation is limited because it uses high-level APIs like the process builder, so we cannot get into the details like file descriptors. And we could implement a library in native code, maybe called libpipeline or libshell, and that we could use it as a foreign interface and include it both in JVM or the ClojureScript version using foreign interface. And with this, we could implement proper job control for which the system calls are needed. And if some more lightweight Clojure implementations comes up, we could leverage that. In summary, what I wanted to present you, there are some great opportunities to innovate in this area, and I'm really excited about it. The Closh is in the experimental phase. You can use it as an interactive shell. I've been doing that for almost 2 years. There are some hard edges and some bugs, but it's overall a great experience. I wouldn't recommend it for production use, but it's great to write some personal scripts, and maybe soon it will get more stable and tested. And you can find it on GitHub. I'd like to thank all people that helped, like Jaren from @Koji and Mikhail, and also thanks all the amazing people at Pitch, which are really great people to work with. Thank you very much.
That was very good and very fast, with the result that we have lots of time for questions.
Yes.
Are you up to taking them?
Yeah, let's do it.
So here we go.
A lot of details.
It's your turn. Over there.
I might be mistaken, but in normal shells, there are, like jobs can almost run in parallel in a pipeline.
Mm-hmm.
Do you have anything like that in Closh so that you can start working on task number 2 before task number 1 finishes in a pipeline?
So not yet, but I'm planning to add that you could use as a future, like a Clojure future. So that would spawn a thread, and then it will run in parallel. And then if you want to wait, so in Bash you have a wait, and with Clojure you could just reuse the existing concepts. So you could defer, which is blocking if it's not finished yet, and if it's already finished, you can wait for other tasks. So I think, yeah, spawning a separate thread is a solution.
Does Closh re-implement the sort of normal shell commands like ls and such, or does it fall back to an existing shell?
Yes, so the great thing is it fallbacks to the actual programs, so to the binaries. And it does not obviously use the bash built-ins. So if you want some functionality, like for example cd is like a custom command built-in because it needs to manipulate that. So you can define the commands to act as a built-ins. But that's the good way that it doesn't, it falls back down to the commands, so it uses the existing commands, like leveraging the ecosystem, and only user can explicitly redefine some commands, so it's not confusing if some other, like if for example functions you can only call them with parentheses, and that's on purpose. Some other like Python-based shells, they do that when you define a function, you call it as a command, but you would override the existing program, which could be very confusing. So there's the method with defining custom command to achieve it, but it's no explicit action to be less confusing.
Hi, can you embed bash inside a Clojure expression?
Embed bash inside?
Like, yeah, write date inside a Clojure expression, for example, and expect to have the string date.
I'm not sure if I understand what you mean, but
just imagine writing parent, open parent, str, and then somehow date in referring to bash date. Correct?
So maybe, so the thing, what you type in the shell is, so you can also, if you type shdate, it's like a macro, and the command line works by the, it takes the input and pass it through that macro, and which does the parsing. So you can call the commands like this.
Oh, I was looking the other way.
How well does Closh cope with commands that produce huge output? Like, can you take a Unix program that produces infinite output like yes and fit that into a Closh pipeline?
Yeah, so if you have gigabytes of data, it might not be the best tool yet, because it uses the Java streams, so it has to get the input, pipe it through the Java stream and get it out. With existing shell like bash, that only does the setup file redirects, and then the kernel does the piping. The shell does not touch it anymore. So currently, if you want to operate on the larger data sets, it might not be best way, and that might be something that we could address with having that native library, using the native syscalls to achieve that.
On that note, one more.
Hello. The new ls function you demonstrated in the demo, do they use the ls from new shell?
So yeah, that's pretty. I'm following other shells. So there's a project called New Shell, which is written in Rust, and they take similar approach, being data oriented, and they already started implementing some of the commands, re-implement them, the classic core commands, to give you data. So for this prototype, I call the new shell data and wrap it to return the data. So I think that's a great symbiosis. It's been great that other shells are going in the similar direction, and we can reuse the work together.
Okay, with that, thank you, Jakub.